Geometry, we're going to take a jump up to Chapter 5, Lesson 4, because this finishes up dealing with conditionals. And so we want to take a look at this now while we're studying these. And we're going to look at inverses and contrapositives. We're not going to take a look at indirect reasoning. We'll just cover these. And so I'll try to do this in one video. It might be a little bit longer than usual, but I only want to do one video and cover everything and give you some examples and talk about truth value as well. So I'll move quickly, but you can again stop it if you need it. The first thing we need to know is what the term negation means. And negation is simply to create a statement with opposite truth value. So if we have the statement here, Knoxville is the capital of Tennessee, to negate that or to write a statement that has the opposite truth value, we would simply say that Knoxville is not the capital of Tennessee. Okay, and then those statements can be true or false. But basically we just want to know what the negation means. It means it has the opposite truth value. So for example, if you said 2 is even, the negation of that statement would be to say that 2 is not even. Alright, so that's what negation means. Now when we're looking at inverses and contrapositives, we're going to need to use negation. That's why we take a look at it. So the inverse of a conditional statement negates both the hypothesis and the conclusion. So that's all we want to take a look at. So the inverse is you take a conditional, which you have, and you simply negate the hypothesis. So you make the hypothesis have the opposite truth value, and you also negate the conclusion. And so by negating both, you create what's called the inverse. Okay? The contrapositive of the conditional actually switches the hypothesis and the conclusion and negates both. So you can kind of think about it as a combining of the converse and the inverse. You switch the hypothesis and conclusion, which the converse does, and you negate both, which the inverse does. So when you do both, you're creating what's called the contrapositive. So the contrapositive, again, takes the conditional, it switches the hypothesis and conclusion, the same as the converse would, and then negates both like an inverse would. Okay, so that's how you create a contrapositive. So very quickly, if you have the figure if a figure is a square, then all its angles are right angles. The inverse would be to do what? Negate both. So if the figure is not a square, then all its angles are not right angles would be the inverse. Okay. Another example, if a figure is a square, then the figure is a rectangle. The inverse would be if a figure is not a square, then the figure is not a rectangle. Again, we negate both. One more example. If you eat all of your vegetables, then you will grow. So the inverse would be if you do not eat all of your vegetables, then you will not grow. Again, we negate both. Okay, so that's how you write the inverse. The contrapositive, now we negate and switch. So if the figure is a square, then all its angles are right angles. We negate and we switch. So this conclusion, the negation of it, if all the angles are not right angles, then the figure is not a square. That would be the contrapositive. We negated both and we switched both. If you eat all your vegetables, then you will grow. If you will not grow, then you will not eat all your vegetables. Negate both and switch both. Okay, and one final one. If a figure is a square, then the figure is a rectangle. Negate and switch. If the figure is not a rectangle, then the figure is not a square. So that's how you write the inverse and contrapositives once you have the conditional. Now, we spent a lot of time talking about truth value, so we want to talk about that again. And just as a review, remember, a conditional and the converse can have different truth values. So just because you have a true conditional does not mean you're going to have a true converse. And when we're talking about inverses and contrapositives, there's some things we need to know about that as well. A conditional statement and its inverse also can have different truth values. So while the conditional may be true, the inverse may also not be true. However, a conditional statement and its contrapositive are always equivalent. Equivalent statements meaning they have the same truth value. So a contrapositive and a conditional cannot have different truth values. They must and they will have the same. So a contrapositive is a conditional, you remember, that switches and negates both, and it always has the same truth value as the conditional. So if the conditional is true, the contrapositive must be true. Remember, the converse and inverse, not necessarily, but the contrapositive must. So if we combine all of these into mathematical notation and what they have, you remember, if P then Q. The negation, we use this little symbol. This means not P. So the inverse, we negate both. If not P, then not Q. And the contrapositive negates and switches. So if not Q, then not P. So that would be the mathematical notation of that. So now we want to look at a few examples where we go ahead and apply this. So here's the conditional. If you live in El Paso, then you live in Texas. That's true. The inverse would be to negate both. So if you do not live in El Paso, then you do not live in Texas. Well, that's not true, because you could live in Houston. You're not in El Paso, but you are still in Texas. So you can see that the conditional and its inverse may have different truth values. However, when we write the contrapositive, we negate. If you do not live in Texas, then you do not live in El Paso. That would have to be true because the original conditional is true. And we can show that that's true. If you do not live in Texas, there's no way that you can live in El Paso, because El Paso is in Texas. So contrapositive and the conditionals have the same truth value. All right, one more statement. If 4 points are collinear, then the points are coplanar. That's true. The inverse then, if the 4 points are not collinear, then the points are not coplanar. That is false. Okay? 4 points cannot be on the same line but still be in the same plane. So again, conditional true, inverse false. Then the next one, the contrapositive, we negate and switch. If 4 points are not coplanar, then the points are not collinear. That is true. They must have the same truth value. The conditional is true. The contrapositive, therefore, is also true. And if we look at it, if 4 points are not in the same plane, then it would be impossible for them to be on the same line, because a line can only be in one plane. So that's inverse, that's contrapositive, and those are the truth values. So this will wrap up what we're learning about conditionals. We'll move on and look at some laws of logic in the next lesson.